It's great. So glad you're here. I do want to start on time. I know there's sort of DU time, which is sometimes starts a few minutes after the hour, and I'm as guilty of it as anyone, but there's a lot of content here. I want to make sure we have time to hear from all of our presenters and also to have time to focus on getting to discuss it. So big picture context here is that what we're trying to do here, spurred by our provost, is pull people together from across campus who are both working on and interested in topics in AI and data. We are thinking about AI very broadly, and that's part of the plan here. So the goal is we're going to do 3 lead-up events, maybe 4, into an April summit, or what we're calling an unconference. And the idea behind each of these events is to make sure that we are starting conversations across the university around people who might have similar interests and see what happens. That's the goal, is to essentially build and nurture an ecosystem around DU in terms of AI and big data. So our kickoff for that, we're really doing the overview today, and that's what we're really glad you're here on a snowy day. First, we'll do the overview. Mohammad Mahoor will do an overview of the technology. Then we'll hear an overview of some of the types of application work that folks are doing at DU, and then we'll hear an overview of some of the policy and ethics work going on at DU. And then we'll break out, and what we'll have is each of the presenters will set up at a table here, and we'll have 2 sessions, so you can pick sort of 2 of the presenters that you want to talk to and learn more, and the question that they will have for you is, what more do you wish you knew? And that will inform our subsequent events. So with that, I will welcome to the stage Mohammad Mahoor.
Hello, everyone. Can you hear me? Yep. Okay, great. All right, it's all there. So today I'm going to give you an overview of what AI is, artificial intelligence, and together have some discussions and also present some slides to you, and also tell you about machine learning and deep learning and so on and so forth, right? So this is just to scratch the surface, of course, right? And I try to keep it as easy as possible and use the later. So artificial intelligence is a field in computer science, right, that deals with making intelligent machines. I think I'm good for now. Thank you, yeah. So it's a field in computer science, as I said, that deals with making intelligent machines. So the term was coined by John McCarty at the Dartmouth conference in 1956. So a group of computer scientists got together in a summer, right, at Dartmouth College, and these are the the founding father of AI, the field AI, and the artificial intelligence basically was a term to describe thinking machines, right? So that's the term and where that is coming from. But the question is, what is intelligence, right? There has been different definitions, right, for artificial intelligence. And in fact, we wanted to create machines, right, that are as intelligent as human. So human intelligence is our target, right? And so people came up with different definitions. And as you see here in this matrix, we have think, right, versus act or behave, versus, we have human and also rational. So if you look at it, so for example, if you wanted to make systems that think like human, that's basically cognitive science or neuroscience. So neuroscientists are working together to see how human beings, right, think and how we can make systems that basically are like humans, right? But the focus of modern AI is to build machines, right, that act rationally instead of just see that how they think. We wanted to know how, that build machines that see how they rationally, behave or act. So said that, people in AI, especially in the early days, they said, okay, we wanted to mimic human intelligence, then let's see how humans, right, behave or act, right? So humans are good at seeing objects. So that's the field of, computer vision, which is a subfield in AI, right? So a group of scientists in AI are working on this, topic. So human being can hear, right? So that's another field called speech recognition, right? And also we can read, right? Or we can write. So that's a different field, and that's called natural language processing. We use this, for communication. So we want to build machines that can do, understand text, and that's NLP, right? Also, human can play chess or games and so on and so forth, or we are experts, to make decisions. So that's a different field, and that is called expert systems. And early on, right, in AI, people focused on expert systems, right? And we can move, right? So moving is, one of our features or acting or behaviors. So that's also how AI is related to robotics, okay? And also we learn, right? We go to school, we come here, right? So we learn and from experience or from data, and that's a different field in AI, and that is called machine learning. So machine learning is the focus of, current AI, that I'm going to explain it, in the next few slides. So like any other disciplines in science, AI has gone, through ups and has had ups and downs. So AI had, golden age, very successful, right? But then it failed to solve some problems. So then we had AI winter. So AI actually had two winters, right? Back in 70s and 80s. And nowadays, you see that AI is everywhere, and everybody wants to do AI, right? To build the smart machines, make it intelligent, and so on and so forth. I don't want to go through, the details of, the AI timelines and see, at each area what happened, at what kind of algorithm was developed, or what kind of machine was built. But to just tell you that, right, people had big hope at the beginning, right? And they thought that by 2000, the millennium, they can build, they can solve all the problems. Basically, they can have an intelligent machine as intelligent as human. But that was just, a hope, and it didn't work out. Anyway, so in early days, the way that computer scientists did AI, it was based on knowledge representation and search. And especially this kind of AI, which is called good old-fashioned AI, has been used, for example, in expert systems or in systems or algorithms that are used for playing games like chess and so on and so forth. Even some researchers, right, some scientists still do research based on this approach, right, doing logic and search and so on and so forth. Make sense? Are you here with me so far? Okay, so there's a quiz at the end. Okay, just. All right, but currently, people, in AI, they are focused on machine learning. So machine learning is a subfield in AI. And oftentimes, we confuse these two terms, right? We just say AI, but we don't know exactly what we mean by AI, right? So specifically these days, right, people, when they say AI, they mean machine learning. And within machine learning, there is a subfield called deep learning, which is even, that more focused, right? And it started about 5, or 6 years ago. So in the next few slides, I'm going to explain to you in simple language what machine learning is, what deep learning is, and how it's related to artificial neural networks. Good? So this is a very basic, right, slides or that the graph about machine learning. So basically, we wanted to learn, we have algorithm, and the algorithm learn from data. And the data that we have, or we can also consider it as experience, these are labeled data, right? So for example, I want to do visual recognition, object recognition, or face recognition, right? So I have an image, and somebody tells me that, in this image there's a cat. In another image, there is a dog, right? So by looking at many, many examples, I learn pattern, right, that to differentiate between them, right? So that is called, machine learning. So we learn from experience or from data. And as you see here, machine learning has two pieces. We have training, so we train algorithm. Once we train the algorithm and we have it, then, for example, you have a novel sample and you wanted to test it. So then from the learned model, right, you wanted to predict or classify and so on and so forth. So this is machine learning. So there have been 3 different approaches for machine learning. One of them is called supervised learning. That's exactly what I explained. Supervised learning means that you know the answer. It's like that you take a class and your professor, right, gives you the solution to the problem. So you learn by looking at the solution, or you know the answer to the question, right? And also looking at the data. So that is called supervised learning. And most of the problem in the field of machine learning is within the, within this approach, supervised learning. So we have another approach that's called unsupervised learning, and that's when we don't know the answer. So we wanted to do data mining. We want to explore the data to see what is inside the data, how many classes, for example, we have, how many labels, right? How the data is structured, and that is called unsupervised learning, right? And that is oftentimes, used in chemistry, in biological science, and so on and so forth. We have another approach in machine learning, and that is called reinforcement learning. What is reinforcement learning? It means that I don't know the labels, but what I know, I know that if you have done something wrong or correct, then I give you a reward. And based on the rewards that you get, right, then you can improve or correct your algorithm. So that's the approach called reinforcement learning. And reinforcement learning has been used a lot in robotics, right? So we use that in robotics because we want our robot to learn, right, by running experiments, right? And then we give them the reward if they do it correctly, so they try to correct themselves if they do it wrong. All right? So there are also, it's good to know that when it comes to machine learning, there are different problem types. So machine learning can be used for data classification, right? So a good example of classification is, in email, right, systems. So the system automatically can classify a mail as a spam or a non-spam mail, right? So that is a good example of classification. We may do data clustering, right? For example, in gene analysis, we can, look for, genes that have problems or whatever, or we can classify them. Another type of problem is prediction. So for example, when we have a stock market, right? We can learn a model, and the model can, do prediction. So this is mostly, based on regression. And another problem is, when you wanted to look for abnormal, patterns in data, right? So that's another, type of problem that we can work on. So artificial neural networks is an approach, or is a, framework, or is a method, right, for machine learning. And what is it? So basically, people try to model, right, the neuron in human brain, and that is, you have inputs at the dendrites. They get collected, all the signals that is coming, and then you have the axon and the branches, right, that goes and activates or deactivates, other neurons. So about 60, 70 years ago, a very simple model of human, neuron was, proposed, and this has been used in artificial neural networks. So look at it that we have a single neuron, and then because in human brain we have a network of neurons, then all of these, act together, interact, right, with each other to build a graph model, a system, right, that is called artificial neural networks. So we can have a single layer neuron, artificial neural networks, or we can have MLP, multi-layer, neural network. So this is called perceptron. So what happens, we have data, and each of these nodes are a neuron that basically are connected. So the data goes through the input layer, and at the end, we have the output layer, which is basically the result that we want. For example, the label, right? So, and in the middle, we have hidden layers, right? That, it's, multiplication of data, right? That goes through these neurons. So what happens in learning, basically we learn the weights. We wanted to know that how data, through each node that goes, right? Then how they are multiplied by different weights, whether they have been amplified or de-amplified, right? So that's how artificial neural network works. So the objective is that to show a lot of sample to this network, right? To find the optimal weight such that when you show it, the right example, you get the right, output. So that is artificial neural networks. So there's a history right behind artificial neural networks. The first model, perceptron, was proposed in 1957, and then a few systems are made based on that. But then, at some point, people said, wait a minute, just a single layer network may not work. For example, XOR problem, right? It's if you have an XOR function, it means that, right, it's the logic, basically. So a single layered artificial neural network could not solve a very simple problem. And there was, AI winter, and for a while nobody worked on this, and so on and so forth. And then later people came up with a multi-layer, perceptron. Basically, at least we say that we need 3 layers, right, to be able to, that do classification or do machine learning, right? And again, went down, and it has had good days and bad days, right? But nowadays it's very hot, and now we know it as this kind of machine learning as deep learning. So deep learning was introduced about 7-8 years ago, and there is a difference between deep learning and the regular or traditional machine learning. So this slide is very important. I want you to just pay attention to this slide so to understand the difference between traditional machine learning and deep learning. So in traditional machine learning, what happens? We do feature engineering. Means that if I wanted to do object recognition from visual data, from images, I look at images, right, and say, okay, cat, for example, what are the patterns, right? What kind of patterns or features I should extract from the image, right? So for example, the texture, the shape, right, and so on and so forth. Once I extract those features, right, then I run it through a classifier. It can be multi-layer perceptron. So for example, if you want to do a speech recognition, then a domain expert should help you, right, to be able to extract the right features. For example, a pitch is good, or frequency is better, or whatever, right? So you see that here, human is involved, human is in the loop to extract good features. Once you extract good features, then you can represent your samples or your data. But in deep learning, we say that we have an end-to-end system. Means that I don't want to spend time, or I don't know, right, what kind of features are good. So let the system learn, right? So basically, you see here, I have more than a 3-layer artificial neural network. I have 7 layers, 10 layers, right? Or even nowadays, some people have built system, right, that has about 1,000 layers of neural networks, right? Just to try, just to test it. But it's interesting that they, went all the way to 1,000 layers. Now they're trying to make it smaller because, if you wanted to run it on a smartphone, then you can, you won't be able to run it. So I just want to make sure that you understand between the traditional machine learning and deep learning. So when they say deep learning, you don't have to extract features. Let the system, learn and extract features. This is a good example, right, of, features that are learned. Yes, 5 minutes. I'm good. Okay, I think I can finish it. So what, the network learns. So for example, here we have used a deep neural network to do face recognition. And as you see, In the first, layer, we learn edges. And then the second, not we learn, I mean that the network learns, right? The second layer, it learns more complex, features like curves, for example, or, parts of, human face. And then at the, other layers, right, as you go deeper and deeper, you see that you see different faces, right? So basically, this is what the network has learned, right? Right, so we don't have to do this, right? In the past, right, 10 years ago, our job was to learn these features, right? So if you look at it, deep learning is basically it's old wine in new bottles, right? So why it's successful? Because deep learning is very data hungry. I mean it, right? So you need data, and big data has helped to be able to train networks. And some of these networks actually takes days and weeks, right, to learn. So the other reason that deep learning has become successful is because of, the computational power of the systems that we have. We have GPUs, right? And these GPUs, graphical processing units, you may use it to play games, right, computer games, or use it as a, as a computation, horse system or power, whatever, right, to run a lot of processing, right? So that's another reason. And of course, there has been some improvement, right, in terms of algorithm. So two key elements, right, or features that has deep learning successful. One is data, you need good data, and also computational power. Without this, you won't be able to, do deep learning. So these are the requirements. As I said, large data set, measurable. Of course, you have to be able to, define your problem and so on and so forth. So as I said at the beginning, right, we have experts, artificial intelligence. So we have also computer vision as a subfield in AI. And computer vision is a field that deals, with image understanding. So we wanted to process images or videos, be able to recognize objects, and so on and so forth. So these are typical, tasks or examples of computer vision. So computer vision, as I said, is a subfield, in AI. And when it comes to computer vision and image processing, we use a special type of neural networks, and that is called convolutional neural networks. And what it is, basically, you define, a set of filter or mask, and you run, through your image, right? So I don't want to get into details of convolutional neural networks. So deep learning has also been very successful and useful nowadays in natural language processing, and the kind of problems that NLP deals with, it's, for example, information retrieval or machine translation. So for example, the Google Translator, the behind the scene, what you see is a deep neural network system, right, that has learned to do the translation. Or you can do sentiment analysis and so on and so forth. Or even you see some question and answering machines, right, like Siri app and so on and so forth. These are based on the deep learning, okay? So these are the subfields in AI, as you see, in this figure. So we have on the top machine learning, we have natural language processing, we have a speech recognition, expert system, right, planning, scheduling, optimization. We have robotics, right, that is related to AI, and we have also computer vision. So you see that AI is a big field. It has subfields, right? But most often when people talk about AI, they mostly mean machine learning, and that's the area that is very hot nowadays. So takeaway from this talk. So, machine learning means that to build intelligent machines that learn to represent the world from experience or from data. Deep learning is no magic, basically. If you look at it, it's a black box, but within that black box, what happens, you have a multiplication of, a lot of, numbers, right? You have weights and you have data. So you do a lot of multiplications, right? Some of these networks, they have more than 60 million, parameters that takes more than a week or so to learn them. And it's really a tedious process, to train a deep learning system. And so the objective is, right, the research to create, more smart, intelligent, machines or systems that make our life easier and so on and so forth. So again, this is important. So deep learning is a subfield of a subfield of AI. So deep learning is part of machine learning. Machine learning is part of, AI. And also deep learning is related to other fields, has connection with many other fields, right? You see that overlap with data, big data science, it's with math and statistics, with cognitive computing, and so on and so forth. All right, I don't know if I'm on time or no. Sure.
Thank you.
Sure, my pleasure. Any question? Do we have time?
We'll do questions at the end. We'll do the clustered questions. So we will have chance to what you'll do is you'll pick two of the presenters and you'll get to ask them as many questions as you want after the presentations. So I realized also I forgot to introduce myself. I'm sorry. I'm Marty Katz. I'm the Chief Innovation Officer for the university and Executive Director of Project Excite, which is putting on this series. So next up, we have Cindi Fukami, who will be talking to us about the types of application work for AI that are currently going on around the university, which will be great. Thanks.
Good afternoon. About a year and a half ago, my colleague Dennis Whitmer from the Management Department and Doug Allen, who's here today from the Management Department, and I started planning a class on the future of work, given artificial intelligence and automation. I'm not exactly sure how the whole thing started, but it might have been Dennis sending us all a Dilbert cartoon, which he likes to do. And if you're a reader of Dilbert, you know Dilbert has been taking on artificial intelligence in the workplace. And we started passing articles around to each other that we saw. And last spring quarter, we delivered the class that we called Robots and the Future of Work. And we're going to offer it again in spring quarter. So if you have students interested in this, we'd love to see them come over and take the class. It's open to both graduate and undergraduate students. And this presentation comes from basically the syllabus of our class and the topics that were identified in all of these articles that we were passing back and forth. So I've kind of loosely called them business and work applications because, again, what we were interested in was how is this going to impact the workforce? How is this going to impact what people consider work to be? And how can we prepare ourselves for this future? So one of the first things we did is we looked at the impact of this on different industries. So we took an industry level dive. And probably the one that gets the most attention is the disruption in the automobile industry. I think you might have already seen that a couple of the big auto manufacturers are actually already exiting the passenger car business. And this is a kind of a shift that's going to take place because passenger cars are not going to be necessary for us in a pretty near future due to autonomous vehicles. Certainly, robots have been used in automobile assembly for many years and continue to be used. This is something that's safety related. It's also cost related, and is being used more and more and more in automobile manufacturing. But it's the autonomous vehicle issue that I think is going to be where the real disruption lies. We had a conference at Daniels last spring. You might have seen the autonomous vehicle that was over by the library, and it was giving people rides around campus. It was from the Panasonic Smart Cities location. The conference was put on by people in our real estate and built environment department, and it brought in experts from all over to talk about the impact of autonomous vehicles. And here's just a list of some of the ancillary disruption that's occurring and will occur because of autonomous vehicles. The auto industry, we've already talked about. They're not going to be selling passenger cars. Nobody's going to be buying them. The oil industry will be affected because gas consumption will significantly decrease. Bus, mass transit will be disrupted. Auto insurance, never thought about that, but we won't be paying auto insurance anymore, so what are those guys going to be selling us? Parking lots, just parking on the street won't be necessary anymore because we'll be dropped off by an autonomous vehicle and then picked up again by another autonomous vehicle. Car rental, when people travel, they won't have to rent cars anymore. Taxis, emergency medical technicians, and last but not least, certainly, trial lawyers will not be arguing traffic violations anymore. The transportation industry, the trucking industry, the delivery industry are all impacted by this. And last spring, we took a very interesting trip to Matt Rutherford's lab where we saw drones in action. And you remember the shocking announcement that Amazon was going to use drones to deliver things, and it seems so far in the future. It's not far in the future anymore. And Doug, in fact, has traveled to Africa and was in Rwanda and saw the drones delivering medical supplies and blood in Africa across distances that can't really be traversed easily by an automobile. So all of that is just related to one issue, which is autonomous vehicles. We also have some disruption in the airline industry, and in particular with pilots. Pilots currently work under a two-pilot rule, which is a nice job security provision in their contracts, but it's also a matter of safety. It's been billed as a matter of safety. You might be surprised to find out that on your last trip, the pilot did virtually nothing to fly your plane. Flying planes is perfectly capable through artificial intelligence, and it might be even a little bit safer. And this is becoming an issue in negotiation with pilots' unions. The pilots are still very concerned about having two pilots in the cockpit, and they have said that they're not going to relax that. The other problem is, though, that there's a huge shortage of pilots that can be hired in the industry. So you can expect pretty soon, I think, we're going to have one pilot in the cockpit. Michael Myers, our colleague in the marketing department, was going to talk to you about some of the marketing applications. He's not able to join us today, so hopefully we'll hear from him a little bit later. Our students introduced us to agricultural impacts, that farms are being impacted by artificial intelligence in planting crops and reaping and all sorts of things, planning for what you're supposed to do. And I see Lorenzo back there, so I have to say the accounting disruptions that are occurring because of basically if there's a task that involves gathering data and issuing reports, it's better done by a machine than by a human. We found a system in place at Intercontinental Hotels where they created an artificial intelligence system. When they rent their own hotel room versus when something like Expedia rents a hotel room for them, Expedia gets a fee for having done that. And so on a monthly basis, they have to gather data on which reservations were made by these ancillary companies and how much money they owed them. You can imagine how much that time that takes. And so they have utilized artificial intelligence to do things like that. And of course, in finance, most investing is done through algorithm now. So financial advisors, that's going to be all disrupted. Healthcare, We took a very nice visit to Mohammed's lab in this class, and we saw the companion robots that are being created, as well as the therapy avatar and things like this. So healthcare is already being disrupted by this. And of course, retail, Amazon pretty much leading the way on that. There are also impacts on the workforce. There's a lot of data on which jobs are going to be lost, which jobs are going to be gained. Our economy is switching. Our employees are switching from working full-time for a company to working in what's called the gig economy. Uber drivers, sites like Upwork or TaskRabbit. There are team collaboration tools that have been developed, in particular by IBM using Watson, and then cobots, the idea that human beings will work alongside a partner robot, and they will work together. I won't go through the 22 disruptive technologies because that was covered primarily by Mohammed. I will also mention there are global issues here, not just in terms of competition with other countries in the industry of artificial intelligence, but also on the use of artificial intelligence within these countries. Reports from Sweden, they're really excited about it. They can't wait for it to come. They think this is really great. Japan and China, a very different picture. Japan and China are pretty advanced in terms of the science of all of this, but they use robots for what we might call kind of creepy things in America. There are companion robots in Japan for people who are lonely and would like a companion. There's a video you can see of a woman who has this companion robot who sits at her dinner table and she feeds the robot at the dinner table. And in China, there are uses of monitoring citizen behavior. And you might have seen about the rewarding with incentives for people who obey the rules of the society. Ethical issues in AI covered, I think, by Nancy. Coming up next, one of the big ones for us is universal basic income. What are we going to do if we don't work and we don't have an income? Right, so universal basic income is being experimented with, highly controversial, but it's another thing that's related to the growing income inequality in the U.S. And who's going to pay taxes on all these things, and what's the government going to have for money? As Mohammed told us, there's a lot in here about decision-making and judgment and trying to get the machine to make judgments like human beings. Of course, we know human beings don't make very good judgments because we have biases. And so there's a lot of work being done now about how to make sure that the decisions aren't subject to the kind of biases that human beings have. And there's a startup here in Denver working on controlling for implicit bias in hiring, mortgage loans, and procurement decisions. And then, of course, we have the whole cryptocurrency business. Lingering questions. Our lingering question was certainly how do we prepare the workforce for this, and especially what's the role of higher education in doing this? Is our current model sustainable? I think the answer to that is absolutely no. And we continue to act as if it's not going to be disrupted, but it will, and we need to get ahead of this. And who's responsible for preparing? Is it the company that's responsible? Is it the government that's responsible? Are individuals responsible? Public policy issues, who regulates this? Who owns data? Work versus leisure, what are we going to do in this workless future? Will that create class differences? And finally, really not a business issue, but I couldn't help myself, space exploration. There's a lot of talk of just leaving Earth and going somewhere else. And that may explain a little bit why Richard Branson and Elon Musk want to do this, because, and they're also both very against artificial intelligence. They're planning on just escaping to Mars. So this just scratches the surface, of course, and I'm happy to talk to anybody who's interested about these topics.
I told Marty I would introduce myself. I'm Nancy Reichman. I'm from the Department of Sociology and Criminology and the Colorado Women's College. And I'm going to take a moment of personal reflection because I can. I arrived at the University of Denver in 1984, having written a paper about computer matching. I came with a long interest in surveillance, and in part of my dissertation research, I discovered that there were these databases that were being used by insurance companies to match claims in various places. They were trying to ferret out double dipping, arsonists, habitual auto theft offenders, and so all of a sudden this new world of surveillance where computers were talking to each other to ferret out fraud was pretty interesting to me. So I wrote this paper, and then in 1985 when I was here, I had a National Science Foundation grant to look at what I now know is good old-fashioned AI as it was being used by Inspector General's offices around the country. And I did that and wrote a few things about it and then sort of left it and didn't know that actually I was part of the AI winter, that things had sort of quieted down and that we weren't doing it. And so here I am, and I just need to reflect on this. Then I was 1 year in. Now I am 1 year from retiring from the University of Denver. And here I am talking about some of the very same issues that I came to the University of Denver talking about. So I'm really thankful for the opportunity that I've had over the course of these years, but particularly now, to return to some of these questions. And one of the things that's been puzzling to me is, why are the questions that are being asked about AI now almost exactly the same as the questions that were being asked in the 1980s? And I learned the answer from Mohammad today. It is, just old wine in new bottles. And in fact, we haven't answered and addressed some of these questions. So Bruce and I have been working on this together. He's not here. So the mistakes that I make as I talk to you are mine, but the mistakes in the presentation are both of ours. Okay, so what we did is and I'm going to go really quickly because I won't have time for conversation. So they're not lingering questions. They are Oh, I have to do it. Jeez, come on. All right, AI. Okay, I did say I came in 1984. Just think about it. Do the math. So we've already covered this, lots of the different domains. We're going to see this, and I think the important part for us as we move forward is that, AI might be what Mohammed's into, but AI is what we're all working with across the university, and it touches each of us in every discipline and every department. When you think about policy implications and you think about sort of consequences, or you're trying to evaluate, it's always really important to remember the promises and match them against the pitfalls. And I think most of the promises have been discussed, so I'm just going to beep my way through these slides. Improved efficiency, optimization, the potential for us to neutralize some of our biases. Whether or not we do that is the question, but the potential is there. Potential for greater equity, equality of opportunity, thinking about ways in which AI can take people who have limitations and work with those limitations and bring them to a different place. We can talk about improved predictability. I mean, some of this I will have lots of questions about, but the reality is that there is lots of potential there. There are things that we can now know that we didn't know before because of deep learning, right? And finally, we can have enhanced commercial, you don't see it, enhanced commercial and financial activity, et cetera. I really want to go quick. So here you can see. And the possibility, actually, for some enhanced human experiences. So there's a lot in the terms of its promises. But the pitfalls are all there. One pitfall that I want to talk about is something that's called database inequality. It's not the case that all of us have the same information in databases. I have a capacity as a pretty privileged person to keep some of my data out of a database. That is not true for a mom who is looking for TANF benefits. All of her information is in a database. She doesn't have any possibility for hiding. I can hide some. I mean, I know that sounds weird because we all volunteer all sorts of information on Facebook, but we volunteer that information. That is not the case for so many people. So that database inequality, like what's in there? What are we making decisions? What kinds of data are machines learning from? And it's not the same for all of us. The other thing is algorithmic, I call it injustice. People talk about it as fairness, representational exclusion. What's in those algorithms? And again, thinking about, start with the data. What kind of data are there? They're building algorithms. They're using that data, not all data. And so what's missing? And we know, we know we're making improvements, but we know, for example, with facial recognition software, lots of problems with black and brown faces. Initially, some of that's been changed, but we know that those are the kinds of problems that we have to continue to think about. Amplified individualism. Again, everything's the personal now. What does that mean? So we're really thinking about us, how do we think of ourselves as communities when we're all sort of data bits and bytes? Lack of transparency and interpretability, that gets down to the algorithms. That is, especially when it's deep learning, like how did you get there, right? How did you get there? You neuron thing going through there. It's like, look at all those layers. And we have to unpack that and say, how was that decision made? And maybe there's a fault. How do we know? And I'm sure there are ways that we can find that out. But for me as a layperson, I don't get it. Privacy and data ownership issues, and outdated legal frameworks. Okay, so those are some, and not all, of the kinds of pitfalls that we can see when we start talking about AI, or the things that we need to think about. And then Bruce and I, lack of regulatory oversight, the same thing. Bruce and I also thought we wanted to throw out some of the big questions. These are not the only big questions. These were just the things that we were thinking about as we were emailing back and forth one late night. Will the advantages and disadvantages of AI and deep learning be distributed fairly across social groups? That is, I know some folks are under more surveillance, but they may not be the same people who are benefiting from the consequence of that surveillance. So we need to know a lot about distribution. What will democracy and democratic representation look like in an era of personalized recommendations and information? Just important big questions that we need to ask is that, what does it mean to be part of a democracy when all of us are fed different pieces of information that are just attuned to us? And what about representation? How can and should we regulate surveillance capitalism? I think I threw out there on our Slack channel, there's a new book by Shoshana Zuboff, who I think is one of the best thinkers around these issues. She wrote in 1988 the book about the smart machine. And she spent maybe a decade, working on this concept of surveillance capitalism. I think we all need to look at it. We talked about the ways business are changing. She is arguing that the underlying structures of capitalism are changing, and how do we regulate that? And where's the power? How do we understand that better? Will automation through AI exacerbate inequality or narrow the gap? I think that's one of the huge questions that should be at the forefront of our thinking. Will the soul and aesthetic of the machine satisfy the needs of the human heart? I think that was a question that the provost asked us to think about. And what about the future of human connections as we think about all of this AI stuff? So again, I don't feel like these are the only questions. They are certainly some of the big questions that I hope we get to think about. And our final slide is, how can we contribute to this public conversation? What are we at DU uniquely qualified to do, particularly thinking about the issues like sustainability, social justice, inclusion that kind of drive us? How do we participate in that conversation? So I think that gives us a good spot. And thank you.